Hello to my C# folks, and this is lab number 2. This week we are going to talk about the wonderful world of classes. We're going to deal with creating objects. We're going to talk about attributes inside of classes, getter and setter methods. We're going to talk a little bit about constructors, overloaded constructors, the static keyword, and how to override the toString method. So lots of stuff going to happen this week. So what I'm going to do here is I'm just going to do an example that's somewhat similar to what the lab is asking you to do, but obviously not quite the exact same, so that you have to still figure out what you're doing. So without further ado, I'm going to open up Visual Studio and I'm going to create a new project. Again, it's going to be a console application, C#. I'm going to call this Lab2, and I'm going to hit next, and create. And that's going to kick me into the Visual Studio window. So when we start off in Visual Studio, there is always going to be this default program that it gives you, and you only have one class, and that class is named Program in this case. It might be named Lab2, or it might be named something else in yours, but generally it's going to be something simple like Program. And what I'm trying to do here is I'm trying to create a definition for another class. What I'm going to do is I'm going to talk about an invoice. An invoice is basically a receipt that you would get when you purchase something from a store. So I want to create a whole new class. In C#, in Visual Studio specifically, it is possible to define the class directly here inside of this namespace. So I could start off and say class and then give it some new class name, and I can put in parentheses here. But as best practice, you should generally put each class in a file unto itself. And so Visual Studio will help you with that. If you come over to the right here in the Solution Explorer and you right-click on your project name and you hit Add Class, what it's going to do is it's going to pop you into the class window and it's going to ask you what do you want to call it. And I'm going to call my class Invoice. And you can see it's creating a new file called Invoice.cs. So I hit Add. And up at the top of the screen here, you'll notice I now have two tabs. One for Program, which is my driver, my main program, and then one for Invoice, which is my new invoice. And you'll see that they're both placed into namespace Lab2. That was the name of the project that I created when I started things, and that's just to keep things organized. So at the end of all this, I'll need to submit two files, one invoice.cs and the other one program.cs. All right, so inside of invoice.cs, it just put in a stub little class for me. So it said class invoice. Done. It has no attributes. It has no way to set or get anything. It has no ability to run or do anything. It has no methods. So we're going to start off and we're going to give it some attributes. So if you think about a receipt, what types of things do you generally have? There's usually some kind of a receipt number. So I'm going to create a private attribute, which is going to be of type int, and I'm going to call it invoice ID or invoice number. Let's do invoice number. All right, and so that's going to be like invoice number 2, invoice number 3, invoice number 4. All right, we're going to have a private date so that we can keep track of what date the invoice was done on. That's probably going to be a string. So I'm going to do date. Obviously, each invoice is for one particular customer, so I'm going to keep track of the customer name. And finally, private, we're going to also have a cost, which we're going to keep track of in a float. Okay, so a couple of things here. Why did I make all of these private? Encapsulation, it's a very good thing. It allows you to keep your information private inside of your object. And so that in order for somebody to modify that information, they have to come through your getters and setters that you're going to provide them. So at this moment in time, over in my main program, I could create an invoice. So I could say invoice. That is the type of the variable. It's of type invoice. I can say invoice, my invoice equals new invoice. And that successfully creates for me a variable, which is called my invoice. It is of type invoice, which is the class name, and it has been created. I've actually went ahead and created one. I could create a second one. I could say invoice, my other invoice, my other voice, equals new invoice. Now I have two of them. I have created one variable called my invoice and one variable called my other invoice. This is very similar to my being able to say int x equals 7 and int y equals 8. I've just created two variables. They're both of type int. These are of type invoice. This one's called x, this one's called that, and so on and so forth. So very similar ideas there. All right, so That's great. I have two invoices, and if I run this program right now, if I hit the little run button, really nothing happens. I just get the hello world, which is what was there in the beginning, and that's coming from this console.writeline. Everything compiled, but it didn't really do anything. It just printed hello world because that's what it's told to do. So let's make my invoice a little bit more useful, because right now I have 4 attributes and I can't actually change any of those attributes. So in order for me to be able to create or change any of them, I'm going to need what are called getters and setters. This is the ability for me to get an invoice number and set an invoice number, get the date, set the date, get the customer name, set the customer name. So I'm going to do this one way, and then I'm going to show you that there's another shortcut that you can use as well. So I'm going to say public, and if we're going to be returning the date, let's deal with the date first. Then it's going to return back a string. So the return type is going to be string, and I'm going to call it get date. And in here, what I'm simply going to do is say return date. Now, what this is going to do is it's going to take the date, which it has access to because I'm inside of the class, and it's going to allow me to return it. And since this method is now public, that means that outside of the class, i.e. in my main driver program, I would be able to say get date, and it will tell me the date from that particular invoice. All right, so that's how I would get it. How would I change the date? Well, if I want people to be able to do that, I would say public void set date, and it's going to take in a new string of a new date, and it's simply going to say date equals new date. All right, and so that's going to allow me to change that. I'm going to put these all to lowercase. I don't really know why I did capital. I think that was just a typo in the beginning. So now they're all back to lowercase. All right, so that's one way in which I can create what are called a getter, gets the information, and a setter, which allows me to set the information for this one attribute. And I can do the same thing for customer name and for cost and all the rest. So if I was real quick going to do the customer name, I would say public string get customer name, and it's going to return the customer name. And then likewise down here, I might have a public void set customer name, and it's going to take in a new customer name. And that is going to say customer name equals new customer name. Now, I'm going to point out a couple of things as I'm typing here. As a matter of fact, I'm going to get rid of that whole line and I'm going to redo it. What I wanted to do was I wanted to set the customer name, which is an attribute that's up here, but I have to remember what the attribute is called. Turns out you don't. Visual Studio is very handy. When I type in C, it gives me all of the possibilities of what I could be about to type. Every word that started with C that I might need to type right here is in this list. So let's go with CUS, and all of a sudden it knows that the most likely thing I meant was customer name. So instead of having to type the rest of it, I'm just going to hit the tab key on my keyboard, and you're going to notice that it fills in the remainder of the customer name. All right, so I'm going to set that equal to new, so I type N, and you notice that immediately it went ahead and highlighted the one that it thinks you're about to type, which is new customer name. And that is correct, so I'm just going to hit tab again. So in reality, the actual keys that I hit on the keyboard were CU tab equals N tab. And Visual Studio filled in all the rest for me, which is really, really nice. It's useful for two reasons. First, you're going to forget what you call things, and you're probably going to typo them, and then you're going to end up with a variable that doesn't work. And so, like, if, for example, I forgot this name, you'll notice it's now highlighting it in red, and when I put my mouse over it, it says the name customer X name does not exist in the current context. It's saying, I don't know what you're trying to do here. Whereas when I took out that X, if I put my mouse over it, it says, by the way, in case you care, this is a string in invoice.customer_name. And likewise, new customer name, it says this is a parameter of type string called new customer name. All right, so that's how you can do getters and setters. So a handy shortcut that you can use in C# is instead of having to directly write these getters and setters yourself, it is possible to go ahead and do that directly on the line where you created the getter and setter. So very specifically, I've done one for date and I've done one for customer name. What I'm going to do is add them in for cost. So just after the word cost, I'm going to put a set of curly braces and I'm going to say get, set, and then I'm going to close the curly braces. and remove that closing semicolon. So what this does is this effectively creates for you a getter and a setter for cost. It effectively does this same exact code. The getter just takes the value and returns it back publicly, while the setter allows you to pass in a value and set it, and that allows you to not have to write out the individual get and set lines for each of these. All right, so that is making getters and setters for each attribute inside of your code. That means that I can now go through and I can actually use the different methods that I have. So in my invoice, if I wanted to set a customer name here, I could say my invoice dot set customer name, and that takes in a new name, and I could pass it enda. So to be clear, I'm calling this object, which is a variable, and I'm calling a method called setCustomerName, and I'm passing that method enda. So it's going to look inside of Invoice, the class Invoice, for a setCustomerName method, and it takes in a parameter that's a string. And sure enough, I have a setCustomerName that takes in a parameter which is a string. So that's how I'm able to set any of the attributes inside of my object. Sometimes, when you're creating an object, it will be useful to be able to set some of the information directly at the time you create it. So, for example, it might be nice right here where I created my other invoice, if I was able to pass in the customer name, let's say Bob, the amount of the invoice, $123.45, and maybe the date, January 1, 2022. So, in order to be able to do this, I have to have a constructor inside of Invoice that takes in those three parameters. And you can see it's very unhappy with me right now because it says Invoice does not contain a constructor that takes three arguments. So I'm going to go ahead and fix that. I'm going to make a constructor over in Invoice. So over here, what I'm going to do is I'm going to add in a new method. The only thing that makes a constructor are two rules. The first is it has no return type, and the second is it must be named the same as the actual class. So my class is called Invoice, so this is going to be public invoice, and it has to take in three parameters because that's what I'm trying to do. The first one was the name, so string new customer name. The second one was the amount, so I'm going to pass in a float new amount, or a new cost, I guess. And the third one was a string, and that was the new date. All right, so now that I've taken in those three parameters, I need to set each of those attributes. So I'm going to say customer name equals new customer name, and the cost equals new cost, and finally the date equals new date. Right, now I'm noticing that I did lowercase for these and uppercase for customer name. I don't know why I did that, so I'm going to stop doing silliness and correct that in all the places. Those should all be lowercase, just so that I'm being consistent with myself. All right, so now back over in my main program, this line is no longer in an underlined state. It is no longer saying that there is no invoice that takes that. The only problem that I have now is that it says you're trying to pass a double precision into a float. So what's happening here is this is being assumed to be a double, and over in my parameter list of my constructor, I'm taking in a float. So what C# is saying is you're downgrading from a double to a float, and you might say, well, what makes this a double? It's just the default. If I want this to be a float, I can simply put an F at the end of it, and now I'm forcing it into a float. And so over here, it will now work. The other alternative will be to convert all these to doubles instead of being floats. All right, so now when I run my program, we're still pretty much in the same state that we were in. I seem to have a build error. There are no arguments given that correspond to the required parameter. New customer name of invoice. Customer name, new customer name. What do I do? There are no arguments given that correspond to the required formal parameter. Lab2 line 9 in program.cs. Right. Okay. So the issue that I now have is, because I've written one constructor that takes in three parameters, there is no constructor that takes in no parameters. Before I wrote this, there's a default constructor that's there that takes in no parameters, but once I give it a constructor, it needs me to give a constructor that has no parameters. So I'm going to go ahead and write another constructor. So this time it's going to be public invoice. So notice that it has the same exact name as the one above. It's still public, it still has no return type, and its name of the method is invoice. That's still the name of the class and the method. But this time I'm going to pass in no parameters. All right, so in this case, the customer name is going to always be Bob because I said so. The cost is always going to be 0, and the date is always going to be December 10th, 2022, because reasons. All right, so those are just defaults. So now if I make an invoice that I don't pass anything to, like this one, the invoice is going to be for Bob for $0, and it's going to be December 10th, 2022. All right, so now we're able to compile and run, but again, really nothing has happened. I've created an invoice, I've set some attributes, but I'm not really doing anything with them. All right, so let's add, just out of curiosity here, let's add in a couple of console.writelines. Again, I'm using tab complete just to speed that up. I started typing C for console and then hit tab and then W for writeline and hit tab. So I'm going to print out my invoice dot get customer name. Okay, so what I'm telling you to do is to, on my invoice, which is this variable right here, I'm asking it to call get customer name and print that out on the screen. So what I would expect is that I'm going to see the word enda. And there it is right there. The reason I'm seeing enda is because I set the customer name to enda on that invoice. Had I not done that, and if I run it, I'm going to see Bob. And the reason that I see Bob is because it has nothing to do with this, because notice that has a capital B. In the case of the default constructor, I always named the customer Bob. So that's why I got back Bob. All right. So the next thing that we did was we have an invoice number, but we're never doing anything with it. Logically, what should happen is that every invoice should have a unique ID. And so the first invoice should be invoice number 1, and the next one should be invoice number 2, and so on and so forth. So anytime that I'm going to deal with an invoice number or anything that is sequentially incrementing, I'm going to need to have another parameter. And this one is going to be private static int next invoice number. And I'm going to set that equal to 1. All right, so I'm going to explain what's happening here, but I'm going to first go ahead and use it. So I'm going to say invoice number is equal to the next invoice number, and I'm going to do that in both of my constructors. Invoice number is equal to next invoice number. And then I'm going to set next invoice number plus plus. All right, and I'm going to copy those 2 lines of code, and I'm going to paste them in my other constructor as well, so that both of my constructors have that same code. All right, so let me go back up and talk about what's happening here. So the first attribute here, invoice number, is not a static attribute. There's no static keyword in there. It's just a regular attribute. And what that means is that each invoice that I create, so if I have 2 separate invoices, each of them is going to have their own separate invoice number. And if I change the one in this invoice, it has no effect in the one in this invoice. But once you put the word static in there, then all invoices that I create share that variable, which means that if I set the variable in any one of them, it's changed in all of them. So the reason that I need these 2 separate attributes is because I need each invoice to have its own unique number. The first invoice should be invoice number 1, the second one should be invoice number 2, the third one should be invoice number 3. But I need another attribute in order to be able to keep track of what the next invoice number is, and that should be shared across all the invoices, so that as I create invoices, this sets the invoice number for me. So effectively what I'm doing is, as each invoice is being created, I'm setting the invoice number to whatever the next invoice number is, and then across all invoices, I'm updating the invoice number so that the next invoice that's created will have the next one. And then just to prove this point, I'm going to go ahead and add in an invoice number getter. So I'm going to do public void get invoice ID or invoice number. And it's not a void, it's an int because I'm returning an int. Goodness. Return invoice number. Okay, so out in my main class, my program here, I'm going to print out the invoice number. Console writeline, my invoice dot get invoice number. All right, So what we're going to see is for my invoice, because it's the first one that I created, the invoice number is going to be 1. So I'm going to get Bob and then 1. Now I'm going to print out my other invoice, which is the other variable, that one here. That's the second invoice that I created. And now I'm going to see Bob and 2, because the second invoice has index or an invoice number of 2. All right, so far we've talked about creating attributes. We've talked about getters and setters, and that can be done either this way or the longer way. And then we've talked about creating constructors, which are what are used when a new object is created. The constructors set various attributes for you. This is the default constructor, which is there by default. It just initializes everything to a empty string and or a 0 if it's a number. I've overridden the default constructor and I've given it a new definition, and then I've overloaded the constructor by giving it another definition that takes in different parameters and does more intelligent things with that. All right, so these are all the ways that I would need to be able to get and set. And you might wonder, why do you have setters and a constructor that both seem to be doing the same thing? And the answer is the constructor is only called at the time that you create the class or create the object. The setters can be called at any time, so it gives you flexibility to do it one way or the other. All right, so the last thing that I might want to do is be able to print out an invoice. Right now, if I attempt to just directly print an invoice, I'm going to get something kind of weird looking. So I'm going to console.writeline, and I'm going to just simply output my invoice. Right, and I'm just going to turn these off so that we're not getting confused with the output on each of these. And I'm going to hit run. So this is the print statement that's being fired here, and I'm printing out my invoice. I invoked the debugger by double-clicking, sorry. And what I got was lab2.invoice. Where's that coming from? That doesn't seem to make any sense. Well, my invoice is of type invoice, and it's inside of lab2 as a namespace. So what C# did was it just printed out the name of the object because it doesn't really know what I meant when I said print the invoice. It doesn't seem to make a whole lot of sense. So that's not what I really want. What I want is that it prints out invoice number 7 to Bob is for $3 or whatever the case may be. So in order for me to be able to do that, I'm going to create an override of a magical method called toString. So this is going to be public, and it is going to be an override of string toString. When I hit tab, you notice that it went ahead and filled in a whole bunch of crazy for me. It went ahead and created a return that returns base.toString. I'm going to change that, and instead what I'm going to return is invoice plus, I'm going to put a space after that, plus invoice number for amount plus cost plus was issued to plus customer name on date plus date. Okay, so effectively what I've done is I've just printed out a string, but I didn't print it, I returned it. Anytime that a object is used as if it's a string, I don't know why there's 2 semicolons there, anytime an object is used as if it's a string, then it's going to call this toString method, which converts the object into a string. And I'm doing that right here. When I do a print, it's implicit that I'm passing it a string that I want printed. But what I actually passed it was an object of type invoice. So what it realizes I mean is take that object and convert it to a string, and because it's having to do that, it's going to use the toString method. So now when I run it, what I get is invoice 1 for amount 0 was issued to Bob on date December 10th, 2022. And if I print out my other invoice underneath that, you're going to see that I'm going to get both invoices with their amounts and whatnot. So each one has a unique invoice ID. They have different values. They have different customers, Bob with a lowercase and Bob with a capital, and they have different dates which were set up. So we've talked about how to define attributes. We've talked about how to do getters and setters. We've talked about constructors and overloaded constructors. We've talked about the toString method. And we've talked about the driver program, which is where you actually create objects and do the things that you're going to do. And so that should get you going on today's lab. At the end of this lab, you're going to have two files, probably an invoice file and in this case, it's an invoice and the program. In the case of that, I think it's a stock item and the program. So that's how you're going to turn in two separate files. You're going to find those in the usual directory under C:\Windows users, C:\users, and then your username, and then source, and then under some directory under there, you'll find your .2cs files. So that should get you started this week, and I will see you guys next week.